Hello, I am Priyanka Chakraborty. In my previous video, I was discussing about the p-type semiconductor, the n-type semiconductor and its working principle. So today I am going to discuss about the p-n junction diode, the diodes and diode circuit. So before starting, I want to say that please like and subscribe my channel for getting my upcoming videos. So the diode and diode circuit is the today's topic. So at first we have to know what is p-n junction. When one side of the single crystal semiconductor is doped with acceptors and the other side is doped with donors, a p-n junction is produced. It is a two-terminal device and it is referred to as a junction diode. A p-n junction can be step-graded or linearly graded. In a step-graded, the acceptor and the donor concentrations in the semiconductor are constants up to the junction. And in a linearly graded junction, the impurity concentration varies almost linearly with distance from the junction. Now we can see that. So this is the figure for acceptor ions and donor ions. The positively charged donor ions are represented by encircled plus sign and the negatively charged acceptor ions are similarly shown by encircled minus sign. Now we assume that there are only holes in the p side and electrons in the n side. Because of the density gradient across the junction, electrons will be initially diffused through the junction to the left and holes to the right. In the process, the electrons and the holes combine with each other. As a result, the acceptor ions near the junction in the p side and donor ions near the junction in the n side are left unneutralized. The unneutralized ions are termed as uncovered charges. The positive and the negative uncovered charges generate an electric field across the junction directed from the n side to the p side. The direction of this field called barrier field or potential barrier. The barrier field opposes the diffusion of electrons and holes through the junction. Equilibrium is established when the barrier field is just sufficient to prevent further diffusion of electrons and holes. At this situation, there is no movement of charge carriers across the junction, since the neighborhood of the junction is depleted of mobile charges. It is referred to as the depletion region or space charge region. The thickness of the depletion region is about 0.5 micrometer. So, this is the figure of depletion region. First figure indicates at t equal to 0 time. This one is for t equal to t1, that means at the next time, and this is for the infinite time period. So this is the p-n junction diode. When one side of a crystal semiconductor is doped with acceptor and other side is doped with donor, a p-n junction is produced. So previously I say that it is a two-terminal device. So this is the circuit symbol of p-n junction diode. This is the circuit symbol of p-n junction diode. So this is the energy band diagram of PN junction and depletion region. First figure indicates the energy band diagram at the instant of junction formation, and the second figure is at equilibrium. So the built-in potential across the junction is that it opposes both the flow of holes and electrons across the junction. So it is called potential barrier. The resulting electronic device that has been made in the community called a PN junction diode, normally a signal diode. So the biasing of a PN junction diode. First of all, we will see the zero bias condition. When no external voltage potential is applied to a PN junction diode, that is called zero biasing condition. Now, if the diode's terminal are shorted together, a few holes, that is the magnetic carriers in the p-type material with enough energy to overcome the potential barrier will move across the junction against this barrier potential. This is known as forward current and it is referred as IF. Likely, holes generated in the n-type material, that is the magnetic carriers, move across the junction in the opposite direction. This is known as reverse current. That means the current that is generated for the magnetic carrier known as reverse current or reverse saturation current. It is referred as IR. The next one is the forward biasing. A PN junction is said to be in forward biased when the positive pole of a battery is connected to the P side and the negative poles connected to the N side of the junction. That is called forward biasing. The forward biasing voltage V supplied by the battery exerts a force on the holes of the P side and on the electrons of the inside of the junction, driving them towards the junction. As a result, the width of depletion region decreases. That means the depletion region for forward biasing is narrow. Now, what is the reverse biasing? A PN junction is said to be in reverse biased when the positive pole of a battery is connected to the N side and the negative pole is connected to the P side of the junction. The battery voltage V pulls the holes in the P side and the electrons in the N side away from the junction. The width of the depletion layer and the height of the barrier increases accordingly. The rise of the barrier height reduces the current to a negligible value since very few majority carriers can now cross the junction. But the number of minority carriers moving down the potential barrier is left unaffected since this number depends on the temperature only. As a result, a small current called the reverse saturation current flows. The reverse saturation current is practically independent of the applied reverse bias, but it increases with the rise of temperature of the junction diode. That means the depletion region for the reverse biasing is white. So we can see that the depletion region is narrow for the forward biasing and white for the reverse biasing. So we can use as a diode as a switch. When a diode is in forward biasing, the current can flow through the diode. So it acts as a closed switch. That means the switch is on, and when the diode is in reverse bias, the current does not flow through this circuit. So it acts as an open circuit. That means the switch is off. In this figure, we can see that when the diode is in forward bias, the light is on, and when the diode is in reverse bias, the light is off. Okay. So we can say that the diode acts as a switch. So this is the overview what we study today. So this is the depletion region, concept of forward biasing, concept of reverse biasing. The depletion region is narrow for the forward biasing, and the width of depletion region is wide for the reverse biasing. So this is the overview for today. So there are some important questions from this portion. So that's all for today. If you like my video, then please like and subscribe my channel. You can also give me some suggestion to improve my videos. If you want to get any idea about any other topics in electronics, please drop it into the comment box. So thank you and goodbye. Stay safe.